So our goal in chapter 8 is to try to figure out what the actual population average is, or the actual mean for some statistic. And we don't have a chance to, get all the data, pull every single person, and figure out what the mean is. So we have to just take a sample. All right, so in this example, I'm kind of recreating the picture on page 343, or something similar to it. When you take a sample, you can find the average of your sample. And so for example, let's say I took a sample and I average out the sample, and this green dot's going to represent that. It's kind of close to the mean, the real mean, but all I had was a sample to work with, not every single person of the population. So my average of my sample is a little bit off from the real mean. Let's say I took a different sample. Maybe the sample was a little better or a little bigger or something, and now it's a little closer to the mean my average was. And I tried another sample and another one. You could take a lot of samples and you're very rarely going to have your average be exactly on the mean. It could happen, but it's going to be rare. And sometimes you could just get a crazy sample and you can really get far away from the mean. All right, so pretend all these green dots represent different samples, and they're the average of that sample. And so what we want to know in statistics is, well, how close does the average of this sample, is it actually close to the real average, or is it like way far off? And we're not accurate enough with just a sample to say this is the average for one of these green dots. But what we can say is if you go a little bit each way, we're confident the mean lies somewhere on that line. And that's what a confidence interval is. You take the sample, find the average of a sample. I'm trying to make all these green lines the same size. You go a little bit each way from that average, and we're saying we're confident the mean lies somewhere along that green line. Going a little bit each way from our sample average. Right. So you can see this one, it didn't work. Because we never have 100% confidence level. There are going to be samples where we go a little bit each way and the actual mean is farther away than that. So in this chapter, as we talk about having like 80% confidence or 90% confidence or 95% confidence, 99% confidence, etc., what's really going on, as we get those higher confidence levels, basically this line's just getting longer. So say this represents like a 90% confidence level, that if we went this far each way from our average, we'd have the real mean. Well, if that was 90, a 99% confidence level would be a lot bigger. See, what we're doing is we're trying to guess what the real mean is, and if you include more numbers in your guess, you got a better chance of being right. So if we include a bigger interval on either side of our sample mean, we have a better chance that we actually hit the real mean. And you see now with these longer lines, we actually, all of them are touching the real mean. So that's what we're doing here in this chapter. Let's look at some of the homework problems. So starting with number 2, I've changed the numbers a little bit so that I'm not answering the problem for you. But basically what number 2 is saying is, we took a sample, we have our sample mean, and then we created this interval that on either side of the mean, and we said we're 95% confident that the average price of gas is somewhere along that interval. And with the numbers I changed to, I said it's somewhere between $2.50 and $3. Alright, so what the question's asking for is it wants you to remember that we always have the mean exactly in the middle of our confidence interval. And then we do the mean plus the same number as we do the mean minus. And E is our maximum error. So in this sample problem I made up, to get from $2.50 to $3 is 50 cents. So to be halfway in between, this has to be $2.75, right? And so this must be 275 plus 25 cents and 275 minus 25 cents. So what the question's asking for, the sample mean is the number right in the middle of your interval. And then the maximum error is, how far you can go either way. In this case, you can go 25 cents up or 25 cents down. And we're saying we're 95% confident that, the real price of gas is somewhere either 25 cents above what our sample said it was or 25 cents below what our sample said it was. So E equals 25 cents for this example I made up. And oops, I put the line over E by accident. All right, let's look at the next one. All right, looking at number 4, again, I changed the data a little bit. We're saying an auto insurance place only had 350 claims for their sample, and they found the average from that sample was that they paid this much money, $1,500 for each claim. And there was deviation for the population of $200. So somehow they know that claims vary by about $200. So all I'm going to do here is find the 90% confidence interval. So we're dealing with the 8.1 because we're trying to estimate what the real average is, what the real average for a claim paid by that auto insurance company is based on our sample, and we know the standard deviation is given to us in the problem. You have to use page 342. The steps are laid out here for you. You got to figure out, well, we know what the average is, right? We know the average is 1,500, and you got to do the average plus the maximum error all the way down to the average minus the maximum error. All right, because the average is right smack down in the middle, your average for your sample, and you're trying to go a little bit each way and say, we're confident, we're 90% confident that the real average is somewhere on that line, a little bit each way. So the steps to find E are laid out on page 342. And the first thing you have to do is figure out what Z sub C is. Don't let that throw you. It's actually pretty simple if you know what page to look on. It's on page A9, table 3B, and either copy this table down or print it out. But it has confidence intervals for the critical values of Z sub C. And if we want 90%, you just go in the table to 0.90, 90%, and it tells you it tells you what Z sub C is going to be. So if you're looking at that table on page A9, Z sub C for 90% is 1.645. And you know what the standard deviation is. It's given to you in the problem. And you know what n is. This is the square root of n, so you just need the square root of 350. And let me pause this and do the math on a calculator. Alright, so you type that in your calculator, you should get 17.59. and we'll round it to. So we can find our 90% confidence interval here. Again, we know what our average from our sample was, 1,500. And if we add $17.59 to that, we'd be at $1,517.59. And what do we get if we subtract 1,500 minus 17.59? This will go in the other way. 1,482.41. So we are 90% confident of the actual average of what our auto insurance claims are is somewhere between this number and that number, somewhere in between there. Now, if you solving the real problem, you have to next find the 99% confidence interval. So if you want to be even more confident, what are you going to do? Well, do the same work here. You have to look up a different number from the table. You'll get a different value. But what you're doing is you're making your guess a little bit bigger, because we're trying to guess what the actual average is. And so if we guess a few more numbers a little bit bigger, we're more confident that we're going to be right. Still talking about that example I did, similar to number 4. Excel can also be a great tool. It will give you that maximum error, the e-value, if you do confidence.norm. Okay, and then we wanted 90%, which means we're 90% sure, and Excel takes the opposite of that. So if you're 90% sure, that means you're 10% or 0.1 unsure. So that's what needs to go in here. So that can be tricky. If you're using Excel and you want the 90% confidence interval, you got to enter 0.1. If you wanted 85% confidence interval, you'd enter 0.15 there for the first number. Okay, so it's always the 1 minus the level you want. And then if you just read what Excel wants, the second part here is your standard deviation and then your sample size. And if you put equals in front of that, oh no. It just rounded on me. So put equals in front of it, it'll pump out the number, and we got 17.58. It's slightly off because of rounding. I think we had a different decimal after the 5.8. But Excel will give you that maximum error value, and then again you have to go from there and start with what the mean was. What did I say the mean was? 1,500. And then you got to add, it'd be F3 here to get the upper limit, and the lower limit of your confidence interval will be 1,500 minus F3. Okay, and again, put the equal sign in front of it. So you get, that's your interval. We're 90% confident that the actual mean lies somewhere between those two numbers. To look at 6 real quick, on page 345, it gives you the formula for figuring out what sample size that you need to use. And this is used so much in practice. We want to say, like, we are 95% sure we're right, or we're 99% sure we're right. Well, to get there, it's going to require that we ask enough people in the opinion poll, or we take enough surveys. So to do that, you just use the formula on page 345. And again, ZC, you have to look up in the appendix in the back, depending on what confidence level you want. And then E